Hi everyone, and let's just discuss the last problem, that minimum edge reversal. So every node is reachable. So this is a standard DP trees problem. I mean, if you solve DP trees problem, that concept is like a rerouting of trees. Okay, so the concept here is a rerouting of tree. I mean, this is the easy version of this concept. I mean, there are like lots of problem can come which will like you feel that okay, so I mean you knew that like okay, so I can solve this problem in using rerouting of dream, but like that seems a little bit hard, but this is the easier version of this concept. Okay, so yeah, like, and this is nothing but like what is rerouting of tree, like don't just think about like, okay, I know I don't know rerouting of tree depend tree. So yeah, like don't just think much, but I'll explain in simpler way. And I also I will also tell you like what is rerouting of tree. I mean, rerouting of tree basically means that at first try to find the answer for one node, any node. Okay, and using that node, I mean using the answer of that node, try to find answer of other node. Okay, so let's suppose you find the answer for the parent, and using that parent node answer, just try to find the answer for the children. That's the concept like here. Okay, so at first I am okay, so the concept of rerouting is this. Rerouting means changing the root of the tree. I mean, repeatedly we change the root of the tree. Rerouting, I mean changing the root. That's why, like here, this is the parent of this is the parent node, and this parent node, like there are two children of this parent node, and at first I am trying to calculate the answer for this. Let the just a second. Let the answer for the parent node is x, and using this value we just have to modify something. Okay, little bit modification, and try to find the answer for this node. And now okay, yeah, like after finding the answer for this, let's suppose the answer for this node is y, and try to find the answer for this node using this y value. This is the correct node and this is the parent node. This is the like this is the concept of rerouting. Okay, I mean, yeah, like just changing the root of the tree. Okay, so I mean, yeah, like I have told you, let's just discuss this problem only here. So in this problem, see this graph. Okay, so in this problem you are given a graph, and you are given an directed graph. Okay, yeah, like 2 is 1, 1 is 3, like this you are given a directed graph, and you have to tell that for each node. Okay, for each, I mean, if your root of the tree is 2, then from 2 you can go to 1, and then you can come to 3, and from 2 you can come to 0. So you just have to tell that. I mean, see here, I can reach to every other node. Sorry, yeah, like I can travel from route 2 to every other node, right? But if you yeah, like, but if you try to okay, so now consider the root of the tree is 1. Okay, so now can you able, I mean, can you reach to every other node? Because see, from 1 to you can reach to 3, but from 1 you cannot reach to 2, because there is no direct edges. So in that case, to reach to you to reach to, so you can what you can do is that just reverse the edge. Okay, and yeah, like just reverse the edge. And if you reverse the edge, see, you will able to reach 2, and from 2 you can reach 0, right? And yeah, like similarly, the question is that what is the minimum number of reversal, yeah, for minimum number of reversal for each node. Okay, so that you can reach to every other node from that node. Okay, so if we consider the 1, then from 1 to reach every other node, what is the minimum number of edge reversal? Similarly for 2, if you, I mean, now I am trying to reach every other node from 2, then what is the minimum number of edge traversal that I need for 2? Similarly you can do for 0, similarly 3, and similarly 1. So yeah, like you have to find the answer for the each node. Okay, and if you see the constant is like 10 to the 5. I mean, anyone, I mean, those who are those who are know I mean basic DFS, then they can solve, like they can able to solve this problem in order of n square time complexity. I mean this is easy, like this is easy, like see, from 2 I can reach to, okay, so let me first tell the that order of n square approach. Okay, that is simple. I mean, order of n square approach means I just try to find. I mean here, yeah, like they have mentioned that. I mean, you don't need to check for the connected disconnected thing. I mean, this is the tree. Okay, so there is no concept of connected disconnected. So yeah, like so the order of n square approach is that. Try to find the answer for the each node. Okay, so if I am trying to find the answer for the 2, then from 2 I can reach to 1. I mean, see, for 2 answer is 0. For 2 I can able to reach 1. Why I can able to reach? Because there is directed edges from 1, and if the directed edges is like this and not this, then to 2, from 2 to 1, from I mean see, from 2 to reach 1, I have to reverse this edge. But since the edge is directed towards 1, so we cannot, I mean we are, there is no need to reverse this edge. Similarly, just have to traverse from the this node to every other node, and if in between these two nodes there is no directed edge, then increase your answer, because we have to reverse the edge. Simple, this is simple. So yeah, like you can solve this problem for 2. Similarly, you can solve this problem for 1 independently, and similarly solve this problem for 3 independently for 0. So if there are n edges, then for every edge, sorry, if there are n node, then for every node if you try to find the answer, then the time complexity will become n square time complexity, because you are going to traverse the whole tree every time. So this will I mean yeah, like this will lead to time limit exceed. So now just try to find answer for the order of, I mean something n log n kind of thing. Okay, and I think I have understand the brute force approach. Now try to optimize the, I mean the initial solution. Okay, uh, let's just consider this tree only, or we can take another, yeah, like this tree is fine. Let me erase this thing. See, at first I'm trying to find the answer for the 2. So what is the answer for 2? Answer for 2 is 0. Here I am storing. Okay, so yeah, like let's just make an answer array. Let's just make an answer array. Make this is 0, this is 1, this is 2, and this is 3. This is my answer array. I mean, what is the minimum number of node reversal? Okay, and let's just take random node. Okay, so in this type of problem, I mean I have told you that how to solve this type of problem. Just take the random node, any node, and just try to find that, I mean just take any random node, any one of the node, consider that node as a root, and try to find the answer for that node. And after that, by taking that node as a root node, I mean from that node, just try to find the, using that node answer, I mean that node value, try to find the answer for the other node. Here I am considering at first 2 as my root node. Okay, so if I consider 2 as my root node, then I'm just trying to find answer for 2. Okay, what is the answer for 2? I mean answer for 2 is 0. I mean yeah, like I have explained you how the answer is 0. Okay, now, okay, so this is done. This is like just do one DFS, try to find the answer for the 2, right? And now I'm trying to answer for the 1. See, when I'm trying to find answer for 1, I do not need to focus on the subtree part of the answer, right? Why? Because I do not need to, I mean, I do not need to focus on the subtree of 1. Why? Because while calculating the answer for 2, I have already considered that I have already calculated the answer. I mean, if there is node in this way, then while calculating, I mean, see, just a second. if a node is pointing to like this, so while calculating for answer, um, calculating answer, I mean for answer 2, what is the like what can be the answer, I mean just move to this position, and while I'm trying to move from 1 to this element, but here there doesn't exist any directed path, I mean directed edges from 1 to 2, I mean I have to reverse this, I have to reverse this edge, right? So like while finding the answer for 2, here I have reversed this edge, just keep this thing in mind. And for calculating answer for 1, I don't need to reverse the again, I mean again, again this node. While calculating the answer for 1, I just need to focus on this edge only. I do not need to care about any other edge. I mean see, I have found the answer for 2, but now I'm trying to answer for 1. Yeah, like now I'm trying to answer calculating answer for 1, and while calculating answer for 1, I just need to focus on only this edge, I mean the edge that is between 1 and 2, and I do not need to focus on any other node. Why? Like this is the important thing. Okay, uh, see why I do not need to focus on any other node, because while calculating answer for 2, I have already considered that all the edges are uh, going uh, going from 2 to somewhere else. Okay, all the edges are going from 2. That is my consideration. I mean, yeah, like by considering this, I have calculated answer for 2, right? So if now I am okay, so see, uh, this while calculating answer for 2, I have already calculated answer, like if there is a edge exist like this, so while calculating the answer for 2, then I just have, I mean I have to put 1 here, I mean I have to uh, reverse this edge. Without reversing this edge, I cannot reach to this node, right? So I have to reverse this edge. I mean now my now my uh, now my edge will look like this, right? Now I mean yeah, like find the answer, I mean I am reversing this edge. Yeah, like this is good example. This is example you will understood perfectly. um, See, uh, yeah, like when calculating answer for this one, I am consider that this node is in this way, and uh, since the node uh, uh, doesn't exist in this way, so that's why I have to reverse this edge. And after reversing, I just increase the answer for the 2, and now this node is like this, right? And now I am trying to calculate answer for 1, and while calculating answer for 1, I already what? I already uh, uh, I already moved the edges. I mean now all the edges are starting from the 1. If we look the subtree of the 1, then now all the edges are pointing downwards. I mean pointing from 1 to other, I mean other nodes. Okay, so now I do not care. And similarly for other part, now all the nodes are pointing from this node to any other node. So we do not have to. I mean now I just have to find that. Now I am coming from 2 to 1. Okay, so if this node is like this, okay, it's okay for 2. But if this node, okay, it's okay for 2, and now I am coming from now, sorry, I mean now I am going from 1 to every other node. Okay, now if the node is like this, for while considering answer for 1, I mean if the node is pointing to that node, then I just have to increase my answer by 1. I mean I just have to reverse this edge. This is the thing. And if the node is like this, then I just have to decrease my answer by 1. I mean answer means whatever the answer for the root node, just do -1, and that is your answer for the, I mean yeah, like the child node. And if the node is like this pointing to the child node, then whatever the answer for the root node, then add a +1, and that will become your answer for the child node. I mean, why? Let me explain this part a little bit. This is like, yeah. So here, this is pointing to 2, and now I am trying to go from 1 to 2. Okay, so I have to reverse this node. So if I have to reverse this node, then I have to add my answer plus 1, because while calculating answer for 2, I do not have to reverse this node. So I am not adding any answer, adding any my I mean any value to my root node. Is it is? So yeah, like that's why I have to add. I mean, I just have to reverse this part. This is the thing. And if it is like this, then while calculating answer for this, then I have to do a minus 1. And why minus 1? Because see, while calculating answer for 2, I am reversing this edge, right? I am reversing this edge means I did this. Now I am trying to go from 1 to 2, but my node is this, I mean but my edge is this, like this. So I have to reverse. So that's why I have to do minus 1. This is a simple thing. Yeah, like the code is simple. What I have told you, like here I'm creating a graph, and this is the multi-set pair, and this pair will tell you that the edges from this to this to this, u to b. Yeah, like create the graph, and I mean yeah, like create the tree. And here, this is the thing, and just do a dfs taking the root node as 0. And this is the reverse, what is the minimum reverse that we need, and then again do the dfs. Just in past dfs I just calculate the answer for that node. Yeah. And for this node is simple thing. If the node is exist, I mean the pointing downward, I mean yeah, like if the pointing upward direction, then minus 1, then plus 1, again calling the thing. I have I mean yeah, I'll give the solution link or solution in the description. If you have any problem, then you can see my solution. And I think if you, I mean if you found this thing little bit difficult, then I'll try it. I mean I'll suggest to, I mean yeah, like I would like to suggest solve one two problem on rerouting of tree. I mean yeah, like dpn tree concept. But yeah, like people are saying like dp, but it's not like dp or something. Like this is simple dfs na, like dfs with little bit observation. I mean yeah, like optimize the problem. Like don't think like okay, this problem is dp problem, and I haven't solved any problem. So yeah, like this is like I mean not like this. Just try to think like this is a simple dfs problem. I mean, yeah, like the optimization that, like yeah, I could not able to I mean yeah, I could not optimize that problem. That's why I was not able to solve this problem. So this is simple. This is a simple difference. Okay. So yeah, like this is the problem. I mean yeah, like this is the three problem. And yeah, like I'll try to upload the video for the, I don't know, like I'm not able to solve the third problem during the contest. But yeah, like I'll try to upload the third problem solution as fast as possible. Okay, so yeah, like if you have any doubt, then let me know in the comment section. Thank you.